So I think everyone's muted, but if everyone except for the speaker could please mute themselves, that would be great. Oh, actually, I guess, David, if you could mute yourself, that would be good, just in case there's any background noise. And welcome to Neumann University's Math Colloquium for the spring of 2023. I'm Ryan Savitz, professor of math at Neumann, and our speaker today is going to be Dr. Russ Goodman from Central College in Iowa. He's going to be giving a fascinating talk today on the minimum portion of the popular vote necessary to win the presidency in the United States. I think this is a really relevant topic. As we've seen in recent years, sometimes people win the presidency with less than 50% of the popular vote, but we're going to see how low that can go. So, Russ, would you prefer people hold questions to the end?
No, I think if folks if there's if you want to maybe moderate any chat that comes in,
Mhm.
don't hesitate to interrupt me if it just kind of seems timely. So yeah, those of you out there, if you want to put a question in the chat, I'm perfectly fine with that. And but then otherwise we can do it at the end too. I don't really care either way.
Great. Yeah, sounds good. So if you have a question during the talk, feel free to put it in chat, and I can bring it to Russ's attention. And then otherwise, we'll have some time for Q&A at the end. So without any further ado, welcome, Russ. Mhm.
Cool. All right. Well, thank you very much for having me. I appreciate it, and thanks, Ryan. And yeah, no pressure, right? It's going to be a fascinating talk, so it's going to be fascinating. Um, but yeah, this is something I've been working on this spring. Um, and yes, the notion of elections and all that sort of stuff is quite timely. But this is also a mathematician's perspective on politics, and so a lot of what we're going to see today is good theoretical math, but blended with at least thinking about what could happen in the real world. So let me go ahead and share my screen and get that going. And Ryan, why don't you tell me if you're seeing my slideshow in full screen mode, okay?
Yes.
We good?
Yep, looks good.
Okay, cool. Yeah, just making sure. Um, so yeah, let's go ahead and get into this. And the title here is narrow margins, winning the presidency with a minimal popular vote. And the main thing is, as we get into this, there are two fascinating articles that this work is based on by George Polya back in 1961. The world was a very different place back then, and Wessel in 2012 in I believe it was a Math Horizons article. I'll have links to those articles at the end of the talk, so if anybody is interested in the references that I'll offer, I'll leave those on the screen. And if anybody is interested in the slides themselves, don't hesitate to put it in the chat or send me an email or get in touch any way you want. But this work is based on Polya and Wessel's work, pushing it forward into the year 2023 and beyond, hopefully. So here's the big picture for today. I'll give a bit of an introduction, talking about what the big question happens to be. I think Ryan shared that a bit just a minute ago. Sorry, Professor Savitz shared that just a minute ago. We'll talk a little bit about elections in the United States. We are specifically talking about presidential elections, of course, but just some details with that. We'll talk about Polya's approach to that driving question. That was his 1961 work that emanated from the 1960 election. And so we'll see some of the mathematics behind what that approach was and how that at least tries to answer the driving question about winning the presidency with minimal vote. We'll do a little bit of analysis and see some of the data. I'll have a link and a resource for anybody who's interested to actually play with some historical data, and also to be prepared for the 2024 data that may or may not come in after next year's presidential election. But we'll talk about the consequences of our solution and where we go with them. And then obviously we'll wrap things up and have some Q&A and hopefully have a good conversation. All right. So what's our background on this? So I'm showing you a map of the United States. Back in 1960, when Polya started thinking about this question, the United States had just changed a bit. In 1959, that's when Alaska and Hawaii entered the Union, And so that made the election of presidents a little bit different, because combining the addition of those two states, along with having a census in 1960, um, those sort of factors change what the electoral college looks like and how a presidential candidate can actually win the election. But what Polya found back in 1961, after looking at that election's results, his result was that he found that 38 states could be earned minimally, and we'll be more specific about that in a little bit. But 38 states could be earned minimally, with 0 votes earned elsewhere in all the other 12 states, and yet the candidate could still win the presidency. And so, by his theoretical estimate, or sorry, by his approach and by his estimate, a candidate can earn only 22.1% of the country's popular vote and still win the presidency. At least that was theoretically possible based on how he looked at that election. So fascinating, and we'll circle around back around to this in just a little bit. Um, but what this begs for, at least a little bit, is a primer on how elections are done here in the United States, how to become president. So this is a little tongue in cheek, but just hopefully we'll kind of roll with it. Um, if you want to be president, right, here's your step-by-step guide. It's a really simple process. So number one, you need to be a natural born U.S. citizen. You need to be at least 35 years of age, and you need to be a U.S. resident for at least 14 years. Those are the rules, and they've been that way for quite a while. Number two, hey, just run for president, earn your party's nomination. What is unsaid there is how much money, time, and effort and energy it takes to do that. But, just as long as you can get through step two, you're good to go. Number three, kiss a lot of babies just for fun, but that's going to help you win a lot of votes. Step number four, okay, earn the popular vote. Now, again, that's a bit tongue in cheek, because that is clearly not the case. What we have found in 1824, 1876, 1888, 2000, and 2016 is that those were years where the candidate winning the popular vote did not actually win the presidency. So we know that can happen. Dr. Savitz mentioned that a few minutes ago. So you don't have to earn the popular vote, but you can. But so step number four, really, honestly, is earn at least 270 electoral college votes. That's the target. That's what every candidate is looking at, and especially every candidate who is data oriented and hopefully as strategic as they should be. They are strategically looking to get to 270 as quickly and as easily as possible. Well, and then if you win, you get to celebrate being president of the U.S., which I don't know how much of a celebration that is. All it is a bunch of work. But anyway, celebrate being president of the U.S. So there's how you become president. But what is this electoral college business? I'm going to guess a lot of you here are familiar with it, but again, just making sure we're all on the same page. I did add a footnote there that those that wonder why it's called the Electoral College, the definition of college is offered down there at the bottom of the screen, just in case you're a little wonky for etymology. But how does the Electoral College work? So our country has 50 states, but if you include the District of Columbia, which the United States now does include, we're going to view our country as consisting of 51 states. And back in 1964, the 23rd Amendment gave electoral rights to the District of Columbia. And so, an electoral standpoint, from a virtual standpoint, DC has 2 quote unquote senators and 1 quote unquote representative. So 3 electoral votes for the District of Columbia, along with all the other states. All the other states, similar to this, each state then is going to have a number of electoral votes coming from the number of distributed representatives in the House of Representatives to them, +2. And the +2 represents the actual senators that each of the states has. And so that's where all those electoral votes come from. The total ends up being 538, 435 actual representatives in the House of Representatives, this 1 representative for the District of Columbia, and then the 2 either senators or virtual senators for all 51 states, including the District of Columbia. So the winner of the presidency needs to have a majority. They have to have greater than half of those electoral votes. And so again, the magic number ends up being 270. And I think, as many of us know, the every 10 years, every decade, the United States is required by law to do a census. And so, as we've seen recently, because we just had a census a few years ago, that some states will gain seats in the House of Representatives and some states will lose. My state lost. And so, if you're interested, I do have a link to a Wikipedia page that shows a historical pattern of how many representatives each state had after each census. I'm not going to click on that now, but if we come back to it in Q&A, we can take a look, or I can share that with anybody in the chat later on. But it's just interesting to see. That's for those interested. That's a totally different question and topic. Really fun to think about. That's the question of what's called apportionment. How do various states get apportioned their state representatives based on the law of the land, the rules that we go by? And it turns out there are a lot of different ways to apportion the representatives, but nonetheless, the U.S. Census plays its role in determining how many representatives a given state gets. And so, again, some states win, some states lose. Okay, so what's our driving question? And this really is, in my mind, I'm a mathematician. This is more of a theoretical question than a practical one. But as we keep going along here, and maybe as we get to our conclusions, you might have that moment of, well, could a candidate actually attempt this strategy that we're going to see here in a few minutes? And I don't know the answer to that. I mean, it's likely it's probably unlikely, but we still want to investigate this because we're math people and we like thinking about these kind of things. So, what is the smallest fraction of the popular vote a candidate can receive and still be elected president of the U.S.? And again, we saw that Polya determined back in 1960 that percentage could be as low as 22.1%. Is that the definitive number? Let's analyze what's really going on here. But that's the big question we've got for the day. And so I'm going to switch over to chalkboard mode here, because mainly because representing math notation using my googly slides didn't work perfectly, but I kind of had fun doing this with a nice chalkboard background. And so this was Polya's approach from honestly back in 1961 as he thought about this. So let's define some notation here. Please, please, please. I know my handwriting is not the best. This is this is actual Russ Goodman handwriting. If there's something that you can't read, please just let me know. Put it in chat or just scream it out. You will not offend me, but I did try to use my best handwriting on this. So what was Polya's approach? Let's define some notation here. Let's let V sub I denote the number of votes completely cast in state I, of which there are 51 states if you include District of Columbia. Let's let R sub I represent the number of representatives from state I. Okay, so votes and representatives. And so Polya's assumption, this ends up being a big assumption in doing his calculations. It ends up being a significant one, and we're going to roll with it to see how that analysis works out, because it does lead us to a really interesting strategy for winning the presidency with minimal vote. So Polya's assumption is that there's a constant of proportionality. That's our K. We're going to assume that there is one K that universally for every single state, so for all states, that the number of votes cast is proportional to the number of representatives in that given state. And so again, that K is universal across all 51 states. So what does that allow us to do? If we sum up the V sub i's, if we add up all of the votes cast across the country, then that should add up to, if we factor out the K, that should add up to the sum of all the representatives that are in the country, in the House of Representatives. And that also, again, includes the virtual representative for the District of Columbia. And so in the end, the sum of those representatives ends up being 436. So 435 for all the regular 50 states, plus one for DC. And we're going to denote with a V the number of total nationwide votes that were cast. Okay, so we're just adding up some numbers, hopefully doing okay so far.
Russ, would you mind there was someone in the chat who asked if you could maybe just explain the abbreviations a little more thoroughly, please.
Oh, sure.
Thank you.
Yeah, the upside down A stands for all. it's referred to as a universal. So this constant of proportionality exists. So a backwards E means that there exists. We're assuming that there exists this constant of proportionality, that for all of the states that relationship holds true. And then down here, this is the capital Greek letter sigma, which means to sum up a bunch of numbers. And so we're summing up all of the votes from the various cast in the various states, and we're summing up all of the representatives in the various states too. And so, yeah, again, if there are questions on like that, don't hesitate to interrupt. So in the end, the notation V represents all the nationwide votes cast, and that's equal to K times 436. All right. So Polya's approach then was to imagine the states that a candidate would actually win the majority of the votes in that given state. So we're going to let generically state S1, state S2, dot, 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 up to state S sub n represent the states that the candidate actually wins in winning the election. So this is an unknown number of one states. I hope I phrased that right. But that n, that value of n, is something we're going to push on here in just a little bit. But we're assuming that our candidate wins n number of states, so we have some notation for that. And so for that candidate to win, remember that magic number is 270. So the number of representatives in state number one that candidate won, plus the two senators, right? So R1 plus 2, this is the number of electoral votes coming from state one. This is the number of electoral votes coming from state two, and so on and so forth. This is the number of electoral votes coming from state N. And so if we add all those numbers up, that number has to be greater than or equal to 270, because again, that's our target for the electoral college. Now there are a bunch of twos here. It turns out there are n number of twos, and so if I add all those twos together, I get 2n. And if I subtract that from both sides, that can show up on the right-hand side of my inequality. So for my candidate to win, I would need, or that candidate would need, the sum of the representatives in the states that they won to be greater than or equal to 270 minus 2n. So we've got a relationship that helps us know when a candidate happened to have won. And again, we're assuming that the number of votes cast in a given state is proportional to the number of representatives in that state. And let's assume for now that the number of votes cast in every single state, which I think we can agree is generally a very large number, right? In Iowa, in Pennsylvania, it's way bigger than Iowa. But in most states, excuse me, in most states, this number is going to be in the millions. So let's assume for a second that it's even, because the difference between 5 million and 1 votes versus 5 million votes is not really too relevant for us in this argument. So let's assume that the number of votes cast is even in every single state. So for every state I. So for that candidate to have won all of those N states, here's what needs to have happened. And I'll come back to the W here in a second. But the K times R1, okay, so let me try to connect the dots for you here. K times R1 is the number of votes cast in that first state. So that's V1. So the candidate to win that state needs to have earned half of those votes plus one, at least, right? So winning a majority of the votes in state one. And then so on and so forth, that candidate needs to win K times RN, half of all the votes cast in the nth state plus one. Okay, so this expression here on the right is just saying that the candidate has to have, at the minimum, a majority of the votes in each of the states that we've assumed that they won. And then the W just represents the winning candidate's number of votes collectively from all N of those states. And if we do a little bit of algebra, this expression on the right, we can factor out a K over 2, and we can add up all of the ones that would show up for each of the states. So there are N states, we factor out the K over 2. So we end up thinking that the number of votes that a candidate should earn needs to be greater than or equal to K over 2 times the sum of the representatives plus N, the number of states. Okay, so just we're doing some algebra. Now, Polya's approach further is if we're interested in knowing the minimum proportion of the vote the candidate could earn, let's go ahead and assume that the winner earns 0 votes in all of those other states. Right? We've assumed that the candidate won one n number of states, and let's assume that they did as horribly as possible in all of the other ones, exactly 0 votes in all those other states. So what needs to happen then? The proportion of the votes that they get, right? The W stands for the collective number of votes that they've earned, divided by the number of overall votes cast across the country, must then be greater than or equal to, well, here's our expression for W, here's our expression for V. Okay, so this is basically a conclusion based on the previous couple expressions. So the proportion of votes earned, we've got an expression for what that should look like, and we're gonna kick that around here for a few minutes. So let's clean it up a little bit. These k's can cancel off. We'll have R1 plus R2 up to Rn divided by 872. So 2 times 436. And then we can separate the n over 436k. So we're, again, doing some algebra here. I don't want to dwell on it too much. I'm perfectly okay to answer some questions, but doing some algebra to clean this up a little bit. We're also assuming, though, that the number of representatives, we had this expression a few slides back, we're assuming that the number of representatives earned by the candidate who won is greater than or equal to 270 minus 2n. This was some algebra we did a few minutes ago. And so for the candidate to actually win, because we want to clean this up just a bit, getting stuck in the weeds here, but for the candidate to win, what really needs to happen? The proportion of votes that they earn has to be greater than or equal to 270 minus 2n. So we're just replacing this expression with something a little bit smaller over 872. And then we've left this other expression alone, n over 836k. So we've got ourselves a relatively clean looking expression for a what we call a lower bound for the proportion of votes that the winning candidate can earn. So let's see what needs to happen for that to be as small as humanly possible. Well, for that to happen, to minimize W over V, if we can show that this is possibly an equal sign, right? That proportion is always greater than or equal to this. But we know that if these expressions are equal to one another, that's as small as W over V could ever possibly be. So is that equality possible? And we'll show that here in a minute. But we also wonder how small this expression can be. Okay, so those are the two things we need to do to think about how small that proportion of votes earned could be. Okay, so let's keep pushing. This is the same expression, the same thing from the previous slide. So when does this become an equal sign? Now, I'm not going to flip back to the previous slides, but the equality of these two expressions happens when the candidate wins exactly 270 electoral votes, because the expressions we had a few slides back ended up hinging on the candidate winning at least 270. Well, if the candidate slides by with the exact target number, 270, then that would put an equal sign here along with the candidate winning exactly 1/2 of the votes in a given state plus one, right? So barely eking out a majority in the states that they won, and 0 votes in all the other states. So we're combining a lot of the ideas that we've had over the last few minutes, and we now know that it is possible for a candidate to equal that smallest percentage of votes that they could earn. Okay, now we can do even better than that. So the n over 436k, um, that number is basically going to be close to 0. 436 times k represented the total number of votes cast in the entire election across the country. Well, that number is going to be in the hundreds of millions. So whatever n is, if a candidate wins, let's say 30 states, 50 states, then this fraction represents 50 over 200 million, 150 million. I don't remember what the numbers happen to be, but this is a fraction that's basically close to 0. So essentially we can ignore it. So how do we make this overall expression as small as possible? This is already virtually 0. Notice this numerator over here is 270, take away 2 times n. So the bigger n is, the smaller this fraction is going to be. And that's what we're looking to have happen. So the bigger n happens to be, the smaller this number is, and the smaller that lowest percentage actually becomes. So if we maximize n, if we make n as big as possible, that tells us how to minimize the proportion of votes the candidate would need to earn. Okay, a little counterintuitive, but I don't know, I think it's kind of cool. Okay, so let's wrap that up. And again, this is the most technical part of the talk here, and we can go back to it if need be. But let's break it down in simplest terms here. All of the algebra that we just went through amounts to, number one, you want to win. The candidate would want to win exactly 270 electoral votes if possible. Number two, do that while winning as many states as possible. Again, kind of counterintuitive, but under the assumptions that we're working with here. Um, we're not interested, that candidate wouldn't be interested in winning California, Florida, Texas, New York, Pennsylvania. Our candidate really should be interested in winning as many states as possible, which means they should be looking at the small states, which is kind of fascinating to think about. Okay. So I'm going to pause for a second here. This is the end of probably the most technical part of the talk, and I'd be happy to entertain any questions about the last few minutes before pushing on to seeing what the consequences um, of this strategy happens to be. So, Ryan, if you want to help me out, if there are any questions so far, I'm happy to respond.
I don't think I see any recent questions since the last one.
Okay, cool. I also wanted to get a sip of water too. All right, well, let's go ahead and push forward here. Um, I'll leave this link up here for just a second before I switch over. But if anybody's interested, I'm going to show you a Google Sheets document that I created not too long ago, where you can kind of play around with this strategy, and I'll show it to you here in a minute. If anybody's interested, it's just tinyurl.com/electoral vote data. I'll give you about 5 more seconds, and then I'm going to click on it. And Ryan, I'll make sure to switch over to that window. Let me know if something doesn't show up here in just a minute, please. Excuse me. Okay, so Ryan, I assume this is showing up okay?
Yes.
Okay. So what you're looking at here, this is a just Math Horizons electoral votes spreadsheet in my, I think this is in my Google Drive. But basically what you see on all the tabs down below are the vote totals from any individual state in the country based on elections going back quite a ways here. I think I go back to 1960 where Polya started thinking about this stuff. And so what you're seeing is the 2012 actual election data. So I have that for all the different elections. Um, the total number of votes, total number of electoral votes, yes, there are 538. Um, the total popular vote, again, hundreds of millions. And what you'll see is each of the states, including District of Columbia, you'll see their electoral votes, and then you'll see the popular vote, the total popular vote um, in each of those particular states. Now, the middle section here represents what's called the Polya solution, and I've got that in each of these tabs. So I won't click through too many of them, but you can see that in each of these tabs. So the Polya solution represents the idea, the strategy that I was sharing just a minute ago. Polya's solution is to win as many states as possible and get to 270 exactly if possible. And so what you'll notice in this spreadsheet is that every time there's a Y, then that actually accounts for the number of electoral votes. What you see highlighted up here actually just sums up all the electoral votes earned. And now notice the popular votes won. I guess what I'd want you to notice is over here for Alabama, Polya's strategy tells me to say yes to a candidate wanting to earn the electoral votes from Alabama. It's only got 9 electoral votes. It's one of the smaller ones. So yes, I would want to earn that. Notice then that this value right here, it is rounded. Well, they're all rounded, but it's half of the total popular votes in that particular state, half plus one. And so every time I put a Y, and I'll put one on here just for fun. Every time I put a Y in a "Did you win the state" column, then everything gets updated. So, for example, if this candidate also won California, then okay, then they really surpassed the number of electoral votes that they needed to have. But also notice that their percentage of the popular vote earned actually went up. So notice this is 27.95 if the candidate won California. But if I take away California, notice that percentage goes down. So this is an interactive spreadsheet then. So anybody wanting to play around with this, knock yourself out. Notice though the Polya solution, I really don't play around with that and edit that too much. I usually suggest if anybody wants to play with this, play with the your solution over here, because you can put Y's anywhere you want, and you can see whatever your strategy is. You can try to get the candidate up to 270 electoral votes, and you can see what percentage of the total popular vote that they happen to earn. So this is an interactive thing. I'm pretty sure I got another copy of it somewhere in my Google Drive, um, but pretty fun to play around with, and to see what the results look like for any particular year. I've got myself set up for 2024. Obviously, we don't know what the results are. This is, I think, just a holdover um, from the previous solution, but I'm pretty much set to go so that when the 2024 election comes around, we'll be ready to do the same kind of analysis. So let me go back to my slides here. So that data is going to be there for you to play around with. Have a good time with that. Um, but the census plays a big role. The next big thing to share with you is that while a candidate should want to stock up on as many states as possible and focus on as many small states as possible, the census does change the target each time, because again, some states win, some states lose. And so what we find here is that the 2010 census applied in three elections: 2012, 2016, and even in 2020, the census results weren't available yet. And so it turns out in those 3 years, the number of states that a candidate would need to win is actually 40 states. But if the candidate earns the 40 smallest electoral vote states, that's what's going to get them the election, but with the smallest percentage of the vote. Now, in reality, do most candidates actually win 40 of the 51 states? That's I didn't actually look that up, but my guess is that's probably a bit high of a number. Um, but remember, our question here is, hey, how do I win the election, but I want this percentage of the vote to be as small as possible? And so what we've learned is that in modern times, really the answer is 39 or 40 votes. And really, since the 2010 census, the answer really ends up being 40 votes. And here's how we can account for that. So with the 2010 census, so here's the information I'm sharing with you. Um, the the number of representatives plus two. So this number being a 3 right here. Whoops, didn't mean to click. Sorry. This number being a 3 means that there are some states that have only 3 representatives plus senators. Right. The District of Columbia is one of those. Turns out there are 8 such states. So 8 states only have 3 electoral votes. How many states have 4 electoral votes? 5. How many have 5 electoral votes? 3. And so on and so forth. And eventually we see, okay, there's one state that has 12 electoral votes, one state that has 13. And then we can do a cumulative sum, because we're wondering how many states the candidate would need to earn to minimally win the election. So these 8 states, then the cumulative sum, if the candidate wins all 8 of those and then all 5 of those, now they're up to 13 total states won. They earn 3 more states, so they're up to 16, and so on and so forth. And what we find is that the magic number is 40, because the candidate will get to 40 electoral votes when the cumulative sum of all of their electoral votes. Notice this is 268. It's not 270 yet. But Polya's strategy, and the strategy that I'm advocating, says that at this point, Once you've gotten to 40 states and you've gotten almost to 268, there are no more small states to add. So the next state that I add is going to have more than 13 electoral votes. I'm going way over the 270 target. So at this point, what I would actually want to do is keep my total number of states at 40, and I would want to trade out. I would actually want to trade out maybe a 12 or 13 electoral vote state. So for example, if I trade out a 12 electoral vote state, I would want to pick up a 14 uh, electoral vote state. That would get my total electoral vote to 270, and I'm still at only 40 states, or I could trade out a 13 for a 15. So 40 states to win still ends up being the magic number, and we see that even using the 2020 census and beyond. In that case, the numbers are slightly different. The rationale is the same. We're accumulating states, we're accumulating electoral votes. But now in this case, if I get to the 13th, the state with 13 electoral votes, if that's my 40th state, I'm at 270. I'm done. If I win those states, I know I will have won. Using this strategy, I know I'll have won with the fewest, the smallest percentage of popular vote. So how low can you go? Right? How far can this go? Paulia made some assumptions here, right? Our algebra, all the work that we've done here had some pretty heavy assumptions, and some of these maybe you've already guessed. I don't know, maybe you didn't. But how would we alleviate those three assumptions? Well, we did assume that there were only two candidates. What if there were three, four? What if there were more? And so part of the rationale for ignoring that is, I mean, we do live in a two political party dominated system right now. And so where do we draw that line? Do we think of having just three candidates? Do we think of more? What do we think of a candidate as being viable or not? Because even when we know there are more than two candidates that are running for the presidency, but how many of them are truly legitimate nationwide candidates? So that's, possibly unrealistic, but something for possibly a student to take a look into. We are also assuming, I didn't say it earlier, but we're assuming that no states split electoral votes, and that's actually not true either. That's close to reality, but Maine and Nebraska do split their votes based on congressional district. So if someone wanted to dig notably deeper into the election results, that person would need to find the votes by congressional district, and then maybe you can fine tune this method a little bit more. I don't know how much of an incremental gain that would be, but looking at Maine and Nebraska might be an interesting topic also. And then finally, that assumption that Polya made was a pretty heavy assumption. When he and we assume that the number of votes in a state is proportional to the number of state representatives. That was a very heavy assumption, but it allowed us to come to a pretty elegant strategy. And so the challenge then is if we don't make that assumption, we've really got to look state by state and rethink our approach, which would be a little bit more tedious work, but that's not the end of the world. But it does beg us to think about something that I'm going to abbreviate as a BILP, BILP. So that notion of state by state results, how do we do this in a more fine-tuned manner? I want to introduce you to another tool that might do the trick for us. So a BILP, a BILP, is referring to what's called a binary integer linear programming problem. And so we can think of this overall scenario, this problem, in a slightly different way. And this is kind of how the spreadsheet was working a couple minutes ago. We can view each state as being binary, 0 or 1, right? Any given state, if I'm a candidate, I either lost a state or I won a state. And so I can label states as either 0 or 1. I have a constraint. So if anybody's ever studied linear programming, every linear programming, every operations research problem has some form of constraints. My constraint is I need to, as a candidate, earn at least 270 electoral votes. And then I have an objective. I want to minimize half of the total population coming from the states that I won. So notice that the electoral votes isn't my goal here. That's a constraint. I want to assume that I surpass that 270 electoral vote threshold, but my objective is to make my total population vote one as small as possible. I want to minimize that. And so this is what's called a binary integer linear linear programming problem. So our problem could be viewed as a linear programming problem, LP. Those are really, really common. I'm teaching those in one of my classes right now. There are problems called integer linear programming problems. And again, what we're looking at is what we're going to refer to as a BILP, and these are studied at depth in quite a few places. Kind of fun to play around with. The nice thing is that Microsoft Excel can really help us with this quite nicely. So I want to go back in time. Let's go back to 1960. And if we take a look at that election, and I hope this is showing up okay. I don't want to get too wonky with how Excel does the work here. Um, but if we go back to 1960, uh, I can use Excel and list off all my states. I can list off all the electoral votes that each state has. I can identify the vote count in each of those states, and I can have that binary result. Each state should be labeled with either a 0 or a 1. And I'm going to ask, or what I did was I asked Excel to do that work for me and to answer the question for me. So if anybody's interested, Excel has a wonderful tool called the Excel Solver, and I use the what's called the simplex linear programming method or engine with this. Um, and so all of those constraints and my objective, I was able to put into the parameters for Excel Solver. So I apologize for just showing you a screenshot. I didn't want to bounce around between windows here. But if I ask Excel to do the work, Excel isn't making the same assumptions that we've made in looking at this approach to this point. To this point, Excel is just saying, how do I get to 270 as efficiently as possible? And kind of funny, Excel found a better result. So back in 1960, it would have been possible to earn 37 states, not 38. You could earn 37, a candidate could earn 37 states, earn 12 million, half of the popular vote, and actually only have 17.71% of the total popular vote and still get to that delicious electoral vote number of 270. Okay, so we've got some really nice tools that can help us now that Polya didn't have available to him back in 1961. And again, I'm happy to share more information on the use of Excel Solver if anybody's interested in that, but it's a really nice tool that can help us out. I did actually do a search just out on the internet for other binary integer linear programming problem solvers, and honestly, Excel was the main tool that I found for what it's worth. So let's come full circle here then. Our background, like going back to that 1960 election. So yeah, back in 1961, Polya was thinking about this, but I'm going to think about this in 2023. Um, you didn't have to win 38 states. You could actually win 37 states minimally and actually have a smaller percentage of the popular vote in winning the presidency. So winning 17.7% of the vote. And I'm not going to flip back to the original map of the U.S., but what you might notice is that in the original work by Polya, Florida was actually a state that was won. And in this case, it's not. So it's not just a change of one state. Several states have flipped from either being one in red or not being one. And actually, if I recall, I believe Pennsylvania was one of the other ones. And now I'm actually curious. I'm going to go back. that's just that's just who I am. I want to take a look at that map again. No, it wasn't Pennsylvania. Sorry, I apologize. But you'll notice that there's a little more white here and here with Polya's approach than what we saw in using Excel. Okay, so I apologize for skipping around through the slides just a bit, but I wanted to see that. So let's get to the end here. So I do want to go ahead and wrap up with that in the end, I've found this to just be a really fascinating question to think about from a mathematician theoretical standpoint. I hope I did an okay job of avoiding any politics or getting anybody upset about any particular state or candidates or things like that. But if you're interested, here are a collection of 4 resources that you might investigate. These are all just shortcut URLs. So Polya's 1961 article in Mathematics Teacher, Wessel's article in Math Horizons in 2012. If you're interested in learning more about BILPs, there's an article in Math Horizons from 2012. And then that spreadsheet I showed you a few minutes ago, you can find that at this is the same URL I showed you a couple minutes ago. Okay, so I can flip back to that if need be in just a minute. But I do want to offer Thanks to Professor Savitz for inviting me to do this. I appreciate your time today. I hope my timing was pretty good. I think I hit it okay. Um, and please don't hesitate to email me at goodmanr@central.edu if you have questions, things you want to chat about. If you're interested in looking at my slides or anything like that, I am more than happy to share. I'll go back and thanks to SlidesGo, because I really like this particular template for googly slides. But if you want to email me, feel free to email me at goodmanr@central.edu. But I'll leave those references up here for just a second. So thank you for your time, and I'll take any questions. Excuse me. Sorry about that.
Hello? Can I be heard?
Yes, David?
Yeah, I have a question. Now, I hope this isn't something that was already addressed, because at the beginning I was monitoring which of my students were here, so I might have missed something. But the one assumption that you made, and I didn't hear you address it again, but the one that seems, I guess, the most fantastical, you said you're assuming that the states that they lose, that you get no votes in those states, right? 0 votes. I can't hear you. I think you're muted.
Sorry about that. Yeah, correct. We would assume that the candidate, if we want them to earn the candidacy with minimal percentage of the popular vote, if it's a state that they didn't win, then we're assuming they got literally 0 votes from that state.
Okay. What has anything been done about this to maybe make it that a little more realistic? Like, one thing that occurs to me is you could look at all the presidential votes in history and see what was the smallest percentage that any candidate ever got in any single state. And I think maybe that might be a more realistic minimum. Anything ever been done with that?
Yeah, that'd be interesting. No, I'm not familiar with that, but I'm jotting that down because that's pretty fun to look at. No, that wouldn't be hard to put together based on election data that's out there, but that would be interesting to see how that might impact the model here. Sure. Somebody's partying. Cool. Yeah, no, that's a great question. And again, I think if there are students still here, there are quite a few off ramps or on ramps, whichever way you want to look at it, to playing with this and tweaking the model, tweaking the approach, making different assumptions. And so, yeah, somebody that would want to look into, like I mentioned with Nebraska and Maine, if you want to look into congressional, votes by congressional district, if you wanted to look at votes by state in historical elections, yeah, there's obviously quite a bit of data out there that you could take a look at. Other questions? Comments? Arguments? I like to argue.
I'll just chime in and say I thought it was really interesting. My students and I were actually talking about this in a class right beforehand, and we were guessing that the minimum would be around 25%. And I actually said, and they'll probably hold me to this, I said I'd be surprised if it was less than 20%. So yeah, it's that 17, man. That's really low. Interesting.
Well, and that's for one particular election. You could, I didn't run Excel on every single election to see what the percentage was. I wanted to come back full circle to Polia's one, but that would also, I should probably run that here later just for fun to see if any of them are. It wouldn't shock me if one was less than 17.7%. You never know.
Mm-hmm.
And actually, it really wouldn't surprise me because there are far more votes being cast now than there were back then, which might make it easier to have a smaller percentage.
Mm-hmm.
I was thinking they might get something as low as around 10% was my guess, but I guess not quite there yet.
Yeah, I might have to offer an update on this and run the Excel.
I guess if you had an election where the losing states, or the states they lost, all cast tons and tons of votes, and the winning states did not cast many votes, then you could have a super low percentage.
Yeah, and honestly, when I mentioned earlier that about that notion of swapping out a state for another state to get to that target of 270. That actually was part of Polya's solution in some years of elections, but not all. So when you want to hit that target of 270 electoral votes, you do want to consider, should I swap out two states if one state has maybe a lot more votes that were cast than another? So that actually does become part of the calculation for sure.
Mhm. And I guess in that case, you could really probably get the percentage as low as you want it to be. I mean, theoretically, it's not going to happen in real life, but if you get, let's say, hey, you lose California and there's, 20 million votes there, but you win Wyoming with 3 votes,
Right. Right.
Sure, you could
Yeah,
win with one vote.
Yeah, or 1. Yeah, could be 1 to
right.
nothing. Sure.
Actually, earlier today at lunch, a colleague asked me about that. Well, what if there was just one vote cast? I said, well, that's fine, but now you got to remember, then you have earned 100% of the votes in that state. And
Mhm.
so you would need a ton of votes cast in the other states that you don't win. But yeah, so there are so many what ifs with this that it's just a fun question to kick around, right?
Oh, and then there's a question in chat, which I could read
Oh
for
yeah,
you if
yeah.
you want. Um, did you ever run the opposite of this? And what is the most popular votes you could win but still lose?
Oh no, actually, that's what's the most yeah, that's
Well,
a
isn't
good
that the
dual
same
problem.
question? Isn't that the same thing? I mean, if
Oh
you
sure,
say,
yeah, because the other candidate would earn
yeah, the other one,
the 100% minus that.
so if it's 70, so if the fewest you can, get to win is 17%, then the most you could get and lose would be the 83%.
Yeah, there you go. Boy, that feels way worse, doesn't it?
Hmm.
Yeah, that's right.
Am I, what you were saying before, when you have to get 100% of the state, but still, I mean, you said you have to win 40 states, right? You said.
Hmm.
So if you really want to be completely theoretical, can't you just get like one vote in each of those 40 states and only one person votes? Then you've gotten 40 votes, and then all the other states, you have 40 votes versus the millions of, and all the other states, everybody voted. You could get like close to 0% then, right? Because you would get 40 votes out of everyone cast in the entire country.
Sure. Yeah, yeah, if we go absolutely theoretical for sure. In reality, we know more than one vote's going to be cast. But yeah, you're right. That would be, that would produce a virtually 0% uh, uh, of the vote earned and winning the presidency. I don't know that anyone would feel good about that, but yeah,
And
five
just another
40 people determine who wins the presidency.
Yeah.
another thought, so being a statistician, it would be interesting, if we looked at all the past elections and sort of, instead of coming up with these hypotheticals that are never going to happen, like one person in a state, came up with basically like, 95% lower confidence bounds or something for each state. And then you could come up with sort of a prediction interval for, in the next, whatever 100 years, what's the least likely percentage of
Sure.
popular vote to have. That could be
Yep.
interesting.
Yep. That'd be a fun model to work on too. Yeah, absolutely. Like I said,
Mhm.
lots of off ramps.
Yes. Any other questions or comments?
Well, I suppose again, still touching on that, you could look at the what's the lowest percentage of voters that's ever been happened in any state in history. So then you could assume the states you won got that lowest percentage,
Right.
right?
Right.
And then the states you lost, you got what was it I said the other day? And my mind's going. What was it I said before? I said you assume that the states you lost had the smallest number of, what was it I said initially? I'm confusing myself.
I'm not sure.
No, at the very first point I made, I said, don't assume you got 0 votes in the states you lost. Look at the lowest. That's right. Yeah, okay, that was it. look at the history and see what's the lowest percentage any candidate ever had in this state. That's in the states you lost. And you would assume that the states you won had the lowest percentage of people voting in history.
Sure.
So I think that would probably give you a more realistic
Right.
balance.
Yeah. I mean, yeah. In the end, I mean, you're looking to kind of cut as many corners as you can to narrow in on the. I mean, we're talking about worst case scenarios here, right? But yeah, that's a good way of looking at it.
What other questions or comments do people have? Any of our students have any questions? Okay, well, I guess that sounds like about it. So this was indeed a fascinating talk. I thought that was really interesting. So
Yes.
thank you very much, Professor Goodman. That was fantastic. And again, thank you to everyone for coming to our math colloquium this semester. We don't have a date yet, but we're looking forward to having another one in the fall. And again, thank you, Dr. Goodman, for coming. And have a great rest of your day, everybody.
Yes, thank
Bye
you,
all.
Russell.
Yep. Thank you very much.